Hello, this is Professor Harvey, and this is part 3 of our analysis on Lab 4. What we had done so far was look through all the different conversations here in Wireshark, and we had looked at a bunch of different information. We found that 60.69 here is the victim, and we looked at the ports that were open on that machine. We figured out that .199 is the attacker here. And it was scanning, doing a port scan. The port scan originated from 55.611 was the port that originated from. These other two IP addresses really don't play much of a role. So these were the key sessions we looked at. There's this. There was the biggest session. If we go back quickly to conversations. Just kind of reviewing here. What we do is we ordered the conversations by the number of packets, right? So this really long one is here, right? This is the really long one. So what I did was I went to each of these conversations and put down the number of the packet that it starts at, right? So I did that by filtering on that conversation. And then going to the main window and looking at the packet number of the first packet in that conversation. And then also noted the time, right? So if your time doesn't look like this, then you want to go to time display format and change it. By default, it's normally seconds since the beginning of the capture, right? How many seconds since the beginning of the capture, which is super helpful if you're just trying to keep things in order. But if you actually want to see when the thing happened, you want it to be, time of year or time of day. The times may not line up. So the reason you see here the different time formats is because you may have an issue with whether it's displaying in Universal Coordinated Time (UTC) or whether it's displayed in the local time for this on your system. So we don't know what time zone this person was in, and we don't know what time frame. So you have to be careful with the times when you go to look at the disk image, because you don't know what time zone that's in. So you have to make sure you have the right time zone. Time zones are very tricky when it comes to forensics. You got to make sure you figure out and correct for whatever time zone things are in. That's why a lot of log files have an option, and it's the default with a lot of things to log everything in UTC. UTC is the same thing basically as Greenwich Mean Time. It's not exactly the same thing, but it's more or less the same thing as Greenwich Mean Time. So anyway, that's all you ever wanted to know and more about time. Okay, so we want to use this time setting that actually shows us the real date and time. All this, the whole capture takes place within, less than an hour, so it's all on the same date. Anyway, so this was how I made a note of the time, the starting packet and the time of each one of these conversations, right? So there's this main conversation here. This was the main conversation in terms of the number of packets. And then there were these two other conversations we looked at before. They both take place with the victim machine reaching out and actually starting a session, going out to the attacker's machine and hitting the attacker's machine on port 443. And we observed previously that those sessions are unencrypted, even though they're over 443. They're not really HTTPS sessions. So those are the next two sessions down here. And another session we had looked at earlier was this one here. And I actually put it up here because it actually starts earlier. If you look at it, right, the time of this session, this is the one where the attacker's machine reaches out to the victim on port 445. This one starts at packet 22735. It starts before all these others, and it's the one we thought was exploiting a vulnerability in the SMB protocol. And you have to go further down because it's not a very long session. It was this one here. If we filter on that, if we look again at that session, what we see is, let's try follow. All right, so what we see is the attacking machine reaches out to the victim machine on using the SMB protocol. You can see the operating systems involved here because the attacker machine gives its operating system version. It's running Windows 2000, or at least it's saying it's running Windows 2000. The victim machine replies back with its version. It's running Windows 2003. And down here, we have this weird string in this packet. And this is really the key to the whole thing. So when you see something like this, what you may notice, so this is the end of that. Okay, so if we get rid of that filter, then we're still in that same packet, but now we can see the entire capture following it, right? So this is that SMB session with that weird packet right here. That session ends. Immediately thereafter, the attacker reaches out to the victim machine, which is now listening on this weird upper port immediately thereafter. And it gets a reset. Tries again, it gets a reset. Then it reaches out on this other weird port, gets a reset. Then it reaches out on this other weird port, and it gets a successful connection. So basically, as soon as this SMB session is over, the attacker starts trying to connect on these higher numbered ports, and it finds one that is now listening on the victim machine, which is in this case 25190. So why is the victim machine listening on this port, right? So this is the start of that long session, and we saw that in this session, then what happens is that the attacking machine pushes to the victim machine this file, right? We said it's an MZ file, and it goes on and on and on. We followed this session. It takes a while to try to follow it in Wireshark because it's really long. But if you remember from the previous videos, this session pushes this long file to the victim machine. And then, so the time sequence of these things is important. One of the key things in forensics always is to develop a timeline, right? So we've developed a timeline here of what happened, and simply the fact that this weird, unexplained session that's clearly some sort of malicious thing going on starts immediately after this weird SMB session makes me think there was some vulnerability exploited in SMB to cause the victim machine to listen on this port. So we don't want that. We want that. So I searched in Windows, in Google for Windows 2003, because we know it's Windows 2003, SMB exploit. And when you search for that, you'll find a lot of exploits in SMB. This one affects Windows 2003 Service Pack 2, and it's this erratic gopher exploit. You'll see this article is from 2017, right? This is one of those exploits that was allegedly stolen from the NSA or the CIA by someone and released. This is probably not the one we're interested in, and I immediately guessed that simply because I'm guessing these exercises were not made in the last year. So it's probably an older one. So you go and look at older ones and you find that there is there are a number of well-known SMB exploits that affect Windows 2003, and the most well-known of them is MS-08067. So Microsoft, this is Microsoft's nomenclature for this vulnerability. The way Microsoft numbers their vulnerabilities is with the year and then a sequential number for the vulnerabilities that they publicize in a certain year. The more common kind of canonical way that vulnerabilities are released is vendor neutral is with CVEs. So CVE 2008-4250 is the same as MS-08067. They're the same vulnerability. And this article here was one of the first articles that came up when I searched that. It was at InfoSec Institute. And it goes into detail on using Metasploit in Kali to exploit this vulnerability. And we'll see what happens here. So this is what initially is, these are the open ports on the victim machine before they start. And then watch what happens. They find the victim machine, they exploit the vulnerability, and then after they exploit the vulnerability, it opens up a command shell session to the victim, and we'll see that the victim is now listening on a new port. It's listening on this new higher numbered port. So that's very similar to what we saw. So what we see in this Wireshark session, or what we saw there when we saw the that SMB session, was we were watching right here. There. So this is the shell code that was pushed probably by Metasploit, because we think this is probably a Kali machine that is being used to attack it using Metasploit. We don't have the evidence for that yet, but this is, they could be using some other type of tool to exploit it, but this is the code that's being pushed to exploit this SMB vulnerability. And so that is used to open up this session. And we saw that in that session, the first thing that happens is, like as we were just saying, that it pushes this other executable. And then my suspicion is that that executable is then executed, and which causes this to happen here, which causes the victim now to reach out to the attacker server on port 443 and download yet more malware. So we're going to see what these various things possibly are. This was another session we saw. There we go. This was another odd session we were looking at before that. We don't know the nature of. This is some other sort of malware session on another, on yet another port. Here we have, in this case, again, the victim machine reaching out to the attacker machine and hitting this. So the victim machine is running on port 16548 here. The key thing is we want to know these ports, because the next thing we're going to do is we're going to go using volatility to the memory in the next video. We're going to look at using volatility at the memory and see what is running these various different processes, what the executables are, and what's happening on the machine in the memory that's behind these various different sessions. So now we've done a lot of we've basically spent 3 videos and the better part of almost an hour and a half looking at Wireshark, because there's a lot here. But now we want to start integrating the other evidence from volatility, and then we're going to look at the disk using FTK, and we're going to see how this evidence all can be put together to develop a full picture of what's going on in this case. So I will meet you on the other side at that point.